In this video, we're going to talk about integration by substitution examples where the du isn't exactly like I want it to be when I get ready to substitute. So if we take a look at this example, first off, I recognize it as integration by substitution because of this expression raised to a relatively large exponent. So if you remember from the previous videos, we're going to define our u to be that expression inside the parentheses, the x cubed plus 4. Our next step is to determine what du dx is. So the derivative of that is 3x squared, making du equal to 3x squared dx. So now the next step is always to determine whether du is present in my integrand. So I do my little checking. I need 3x squared dx. So when I go back and look at the integrand, I've got my dx, and here's my x squared, but I need it to be 3x squared. So I'm missing that constant of 3. I'm missing that factor of 3. Now, as long as your integrand is only lacking a constant factor, a 3, a 12, a 2/5, we can fix it. If it's lacking a variable, like you need an x squared and there's only an x there, that's a problem where we have to solve it another way outside of this technique. So for our purposes in this class, if our integrand doesn't contain exactly what du says it should be, it should only be off by a constant factor. So we're off by a constant factor of 3, and here's how we're going to fix it. So we're going to just make it have a factor of 3. So in other words, I'm going to start by rewriting this integral, making it have what I want it to have. I want it to have 3x squared, x cubed plus 4 to the 5th dx. I want to make it have what I need because now it matches. I need a 3x squared, there's a 3x squared. I need a dx, and there's a dx. So now that we have what we want to have, we've got to undo what we did. Wouldn't it be nice if we could just make it what we want it to be and move on? Well, we can't make it what we want it to be if we want this problem to be equivalent to what the problem was that we were given. So we've got to undo this multiplication of 3. Well, how do you undo multiplication? You divide, or you multiply by its reciprocal. So what we're going to do to undo this factor of 3 that we put in there is we're going to divide it out in the end. So we're going to put this 1/3 out there to remind us that once we integrate, we've got to divide that factor of 3 out that we put in order to make this technique of integration by substitution work. Okay, so we've got everything we need, so we're ready to make our substitution of u. So remember that x cubed is going to be replaced, x cubed plus 4 is going to be replaced with our u, and these two terms are going to be replaced by du. So my new integral is going to look like this. I'm going to have the integral, I've got to carry that 1/3 with me now the rest of the way. I'm going to have u to the 5th, and then these two become du. So I'm going to integrate 1/3, or I'm going to take 1/3 of the integral of u to the 5th. So this is a fairly simple power rule integration. So if we go ahead and integrate, I want to keep that 1/3 with me. So I'm going to have 1/3. Then I'm going to do my integration, and I'll just put my integration in here. So coefficient over exponent plus 1, u to the exponent plus 1, and then my constant of integration here. So this is going to equal 1 over 18. I'm just distributing the 1/3, u to the 6th, and then my plus constant. So last step, we need to put what u was back in the problem. So remember up here, u was this x cubed plus 4. So that's got to go back in here for my final answer. So I'm going to have, for my final answer, 1/18 x cubed plus 4 raised to the 6th power plus c. So even if our integrand doesn't have exactly what we want, it's fairly simple to get what we do want. Let's take a look at another example. So again, the recognition that this is a substitution problem is because I've got the square root of a sum. So I can't just simply make that, I can't distribute that 1/2 power and make this into a power rule problem. So our substitution is going to be that u will become the radicand. So we want that u to be the expression underneath the radical symbol. And du dx is the derivative of that. So the derivative of that is 2x. And then solving for du, we have that du is going to be substituting for 2x dx. So the next thing is that check. I want to make sure that 2x and dx are in my integrand. So when I go to look, I've got my dx, but my 2x isn't there. I've got a 3x instead. But remember, the difference between these 2x and 3x is the difference of the constant factor. The variable matches perfectly. I just need to change the coefficient on that variable. So that I can do. So we're going to first rewrite this problem to make it look like I need it to look. So I want that to be 2x times the square root of x squared plus 8 dx. So that I can now check this off. 2x, got it, dx, got it. And so we have what we need. But now I have to remember that out front, I've got to undo what I did. So remember, to get rid of what wasn't there in the beginning, we're going to divide that out. But in this case here, I don't want to just get rid of the 2. I want to put back in what was there. I want to put back the 3. So instead of multiplying by 1/2 to get rid of the 2, I'm going to multiply by 3/2, because that will get rid of the 2 but put the 3 back in. So I will be back to that original problem. Okay, we're ready for the u substitution. So I'm going to have a new integral with that 3/2 out front. And I'm going to have a u underneath that square root sign. I'll write it as the square root of u. And the 2x dx becomes my du. Now to integrate this, I would like to change that square root of u to u with a 1/2 power. So that way I can integrate using the power rule. So integrating using the power rule, I've got my 3/2, and then I'm going to integrate, and I'll have my constant of integration. So to integrate u to the 1/2, I've got the coefficient of 1 over the exponent plus 1. So if I add 1 to that old exponent, I'm going to divide by 3/2, and my u will be to the 3/2 power. So now in this next step, I'm going to simplify that coefficient, and I'm also going to put what u was back in the problem. So it's going to look like this. So we're going to have 3/2, and in here I'm going to have 1 divided by 3/2 is 2/3, and I'm going to put my u back in. So remember, my u was x squared plus 8 raised to the 3/2 power, and that's plus c. And then last, I'm just going to distribute this 3/2 out here to that coefficient for an overall answer of, well, the 3/2 and the 2/3 divide to 1. So I got x squared plus 8 to the 3/2 power plus c. So even when I don't have a number that I need, and there's an extra number there that I don't need, like in the case of this 3, I can still make it work. But remember that in order to make it work, don't forget the fix out here. So you always want to divide out what you put in, multiply back in what you took out.